Hello everyone, welcome to data visualization class. In this tutorial video, we're going to show how to create a simple 3D bar chart in Python. So let's take a look at one example. We want to visualize the sales data in this 3D dimensional space. So the sales data Q1 equal to 10 unit, Q2 we have the 20 unit sales data, and then all the way to Q4 we have 24. So we want to visualize sales data in a vertical bar and showing in this 3D space. So before I show you how we do that in Python, and I want to share with you the logic behind of this visualization. So first of all, you need to define sales data. So this is a fundamental element for the data visualization. Once you have the data, you need to set up 3D space. And this 3D space is you create the environment for holding all of this data. And then we're going to set up the position for each bar, because in the future, you're gonna correspond each position of the bar to Q1 all the way to Q4 to match with the labels of these sales data. So once you have the data, you have the 3D space, and you have the position, and you just put everything together to complete this visualization. Okay, so let's go back to the Colab, and I will show you how to do that in Python. Okay, so this is our data. This is our notebook. And then we just add, first we need, okay, so first of all, you need to import some libraries. We need a matplotlib and NumPy. And first of all, you need to define the data. And this data can be break down into two lists, right? The first list represents sales, and this list is including all the integers. And we have quarters, and these quarters include all of these Q1 to Q4, so just the name for each sales data point. Okay, so this is how we define the data. And then we need to create a 3D space. So just as previous previous video showed, we're going to do this way. Fig equal to plot dot figure. And we're going to set up the fig size. Fig size equal to, let's say, 6 by 6. And then you create the 3D space based on the figure. So we define x, and x equal to fig dot add underline subplot. We use this function to specify the 3D setting. So projection equal to 3D. Okay. So this is how we set up the 3D space. And then next step is to create the position that corresponding to each bar. Remember that in our sales data, this is a list, right? And the position should match with the length of the list. Let's say your sales data maybe have 12 sales data points, then your position should be 12 as well. So it basically represents the length of the sales. So we define x position. This is a variable, and this variable equal to NumPy array. And we're going to pass the length of the sales. Okay, and since the sales is 4 in here, so we have 4 position to hold each bar. And the last we do the plot, because we have everything ready for the visualization. First we need the x bar function, and this function just help you visualize the bar chart. So we pass the dimension of each dimension of the data. So let's say we're going to pass x position, because this is just for the x-axis, and in the future it will corresponding to each quarter, right? And this is one dimension. Another dimension is the sales data. So different sales represent different lengths of the bar. So that should be sales. Okay. and we're going to use plot.show. So I want to show you what this result would be, and you will find that the result is very interesting. So let's do that. Okay, so this is your interesting result, right? And instead of those bar charts are in the vertical position, they're just laid down, okay? So you can see that because we specify 2 dimension here, because this bar chart is like 2 dimension. You have the x-axis and the y-axis, but this is this 2 dimension data is located in a 3D space, right? When you pass the x position, Python will automatically think this is the x-axis, and the sales would be the y-axis, right? So sales would be y-axis. However, you want to make the sales to be vertical. So how would you do that? And one way to do that is to switch the axis, right? So far the sales is in the y-axis, but you need to change the sales to the z-axis so that your sales or the bar will become a vertical, right? So how do we do that? We're going to manually adjust the direction of the z-axis. So z direction equal to y. Okay, once you specify this in the function, let's rerun the cell. Okay, now you can see that, okay, all of the bars are in vertical position, and that is awesome. This is exactly the result I want to have. And then you can see that we need to adjust the axis. For example, this is our x-axis. We need to match the x-axis with different quarters, right? So how do we do that? We're going to use axis set x-ticks. And because x-tick should represent each position, and we're going to pass the x position in here. So let's rerun the cell. You can see that, okay, now the x-axis represents the first position all the way to last position, and in the future we're going to replace those positions to the name of the quarters. So further we're going to set x and set x takes a label, and then we're going to just pass the quarters in this function. And in this way, your quarters Q1 to Q4 will cover the original label and represent the Q1 to Q4 for all of the bars. So let's rerun the cell, and you can see that here my x-axis would be from Q1 to Q4, and this vertical line represents the sales, okay, from 0 to 20. And we need to remove this one, right? This is just additional data, redundant information I want to remove. So how do we remove this dimension? This is a y dimension. How do we remove all of these values in the y dimension? We can do this way. We can use axis set y ticks. And inside of this function, we just pass a bracket in here. And let's rerun the cell. Okay, once you pass the bracket inside of this set y-ticks function, it just remove the data from the y-axis. Okay, that's it. It's very clean and well organized. So this is how we create very simple 3D dimensional bar chart. And I hope you like this video, and I will see you next time.